All right, we're looking at lesson 11. This one now we're interpreting graphs of proportional relationships. So what can we tell from the graph and points that are plotted on the graph? So this first one here just gives us a graph and says, what could this represent? So we get to kind of pick. So one thing I just said is how much water you're drinking each day over the number of hours. So here, as you can see with this point right here, in 16 hours you drink 12 cups of water. So my X here would be my hours, my Y would be the number or how much water I've drank in. So to find the constant of proportionality, we just take our Y divided by our X. So, whoops, we know that 16 here is our Y. 12 is our, sorry, I did that backwards. I did X over Y. 12 is our Y. 16 is our X. So when you simplify this, 4 can go into both these, and that would be 3/4. So you're drinking about 3/4 cups of water, or 6 ounces each hour. Okay. So to give the graph a title, just put water drank by the hour. So something simple. You could come up with something else, something that uses 3/4 for every hour or for every increment in the X, but for me this is just one that I thought of. Okay, and so up here, continuing on with that graph, it says there is a point on the graph. What are its coordinates? So it's 16, 12. Remember, X is always first, Y is always second in your coordinate pair. Okay, what does it represent in your situation? So in this situation, that you drink 12 cups of water in 16 hours. Okay, we can also use that once again to find the constant of proportionality, to find what we're drinking per hour, which was 0.75 cups an hour. Okay, let's go ahead and look at this next one. It says, Tyler was at the amusement park. He walked at a steady pace from the ticket booth to the bumper cars. The point on the graph shows his arrival at the bumper cars. What do the coordinates of the point tell us about the situation? So it tells us how far he went in 50 seconds. So distance in 50 seconds. So he went 40 meters, in 50 seconds. Okay, it says the table representing Tyler's walk shows other values of time and distance. Complete the table. Next, plot the pairs of the values on the grid. Okay, so here's the table. So at 0, 0. He was right there at 20 seconds. He was at 25. Okay, at 30, he was at 37.5. And then at 40, he's at 50, so that one's there. And then so at 1, it'd be about right there. That would be 4/5. Nope. Once again, I'm doing it backwards. I'm doing X over Y. So to find at 1, it's going to be your constant of proportionality. So 50 over 40 is equal to 5/4 or 1.25. Okay. On a table, if it's a proportional relationship, whatever your X is, when your X is 1, your corresponding Y value is always going to be your constant of proportionality. Once again, to find our constant, it's always our Y divided by our X. Okay, what does the 0.00 mean in this situation? This is just, he's starting right next to the, let's see, the ticket booth, is that right where he's starting? Yeah. He starts at the ticket booth. Right, he's right there, so he's away. So he starts at the ticket booth. That's what that 0, 0 means in this situation. Okay, 4, how far away from the ticket booth was Tyler after 1 second? So once again, we found that by taking 50 divided by 40. That gave us 1.25, oops, is 1.25 meters in 1 second. Okay. And so that would be this point right here. So at 1.25. Okay, with how small this graph is in its increments, it's hard to see. Okay. So there we've covered all those questions. Okay, next we're going to move on to 5. So this one's still asking that question. What is the constant of proportionality for the relationship between time and distance? What does it tell you about Tyler's walk? So this will tell us our speed. So once again, that was 1.25, which we found by taking 50 divided by 40. So, and that correlates to his speed. Is 1.25 meters per second. Okay, right here it says, are you ready for more? If Tyler wanted to get to the bumper cars in half the time, how would the graph represent his walk change? How would the table change? What about the constant of proportionality? So here everything would have to double. And so his speed would have to double. So he would have to be going 2.5 meters per second. And his x's would stay the same, but now the corresponding y's would all be doubled. So let's see, at 20 it was 25, 37.5. So now it would be, so he reached his destination of the bumper cars in 20 seconds, because in 20 seconds he would have went 50 meters. Okay, so the graph itself would increase faster. So I'll go back here and just draw. So this would be right here. So this would be there instead of this path here. Okay, so it increases quicker. All right, next problem, it says seagulls eat what? So 4 seagulls ate 10 pounds of garbage. Assume this information describes a proportional relationship. Okay, so we know it's proportional. So it says plot the points that show the number of seagulls and the amount of garbage they ate. Okay, use a straight edge to draw a line through the point, through this point and 0, 0. Okay, because remember, a graph that is proportional is a straight line and passes through the origin. So 4 seagulls eat 16 pounds, I believe is what it was. Nope, sorry, 10 pounds. So at 4, go up to 10. So there's our point. Okay, now if we draw a straight line, okay, there we have our graph. Okay, so we've done 1 and 2. Okay, 3, it says plot the point 1k on the line that is the value of k, or what is the value of k? What does the value of k tell you about this context? Okay, so at 1, we're right at 2.5. So 2.5 So, and I got that because I took 10 divided by 4, and that is the pound of garbage one seagull eats. So that's what our K represents in this context. It's the pounds per seagull, or pounds of garbage eaten by the seagull. Okay, and that looks like that's all. So that's using graphs, using points, using tables to interpret what the graph is going to look like and what it tells us. And so remember, anytime that you're given just a point on the graph that is a proportional, you can use your X and Y to find the constant of proportionality. But that is only if it is proportional.